Good evening. My name is Scott Jarrel. I'm with Intertech. We manufacture geothermal. This is Kortney, who is with Midwest Geothermal. What are we going to talk about tonight? Yeah, geothermal. But more importantly, big buzzword is net zero. So we thought we would focus in on how geothermal helps you get to net zero. And so just starting off, let's go ahead and start off with the question, because otherwise I will completely forget to ask it. But on average, how much of the home's energy is used to condition the space and the water? Any guesses? 50%? Anyone else?
70.
Well, sir. 80.
Yeah. You know what? I'm going to go with 70%. Otherwise, we'll be here all night. So, Brett, reward this young man over here. But really, where we land, and it is an average, so I think you're right there, is basically 65%. So 65% of a home's energy goes into conditioning that space and the water it uses, or the hot water. So with that being said, one of the first things, and this may surprise you because we're in the HVAC industry, but the first step in getting there is tightening that envelope. Because no matter whether you're using geothermal or air source heat pump, you're tightening that so you use less energy, or you're losing less energy through that envelope. And then next, you want to look at that home's energy usage and start with that big bite of 65%. So we're going to tackle that, and we're going to explain where geothermal fits into that. And then, of course, again, we're not here to talk about solar or solar batteries, but then you would follow that up after you've tightened that up so you're not losing energy and you're operating it as efficiently as you can inside. Then you look at, okay, how can I offset the rest of the cost of running that home by producing my own power? And that comes with your solar panels and or batteries as a last step. So, a geothermal unit. A geothermal unit, basically a good way to explain that is that it gives you, for every unit of electricity that you use in a home, it's going to give you 4 to 5 units of energy in return. So that is why it brings it down your load so much in that home. So they're about 400% to 500% efficient compared to conventional equipment. And again, I don't want to slight anything in the air source. They've come a long way. A geothermal is still going to be that much better. So how does it work? How does a geothermal work? Well, it may, the slide's not showing completely here. All right. Let me see here. Sorry. Yeah, that threw me off a little bit. There we go. Sorry about that, guys. But we're going to talk about solar. I don't know how many of you have ever thought of geothermal as a solar system. Not the solar system, but a solar system. Because that's exactly what it is. What we're doing is we're taking our energy grid, if you will, the loop, and we're burying that down into the solar battery. The sun gives off its energy, and it's absorbed. 51% of that is absorbed into the earth. So that is our renewable source of energy. So we'll take that in the summertime, and we will go down into around here about a 48.
The average ground temperature here is 50 to 48 degrees.
48 to 50 degrees in this area. So in the summertime, we're going to take that 48 to 50 degree temperature, and we're going to take the heat out of the home, and we're going to take it down into that cooler dirt where that heat exchange is going to take place. Or in the wintertime, now your 48 to 50 degree temperatures is going to take that, as that water transfers through the ground, is going to pick up that energy again and deliver it right back into the geothermal unit. So does that make sense to everybody? I'm sorry. I'm the automation here. I hesitate to say this, but I live in Ohio, and so me and Kortney. Thank you for that. Where'd that come from, by the way? All right, there's two of us here. We'll walk out together for safety purposes. So I'm going to turn this over to Kortney, and she's going to get into what the ground loops, what the types are, and so on and so forth. So.
Awesome. Well, my favorite part of tonight is how much HVAC we're talking about, because I go to a lot of these, and it is the least thing we talk about when we talk about electrifying a home. Because as much as I love compact fluorescent LED lights, I don't care how many light bulbs you replace, you can't get to net zero without taking care of your space conditioning. So yay, HVAC, even though it's kind of boring to listen to for a really long time. So I appreciate it, but I am from Michigan, based right here in Grand Rapids. But I'm going to talk about types of installations because that is what I do. So we'll talk about slinkies first. That looks like a whole lot of pipe in the ground. But a really great place for a slinky system is under a soccer field or under playground equipment, somewhere that we're not going to build on, but it's green space that we just don't really do anything else with. So what a great place to bury some pipe. This actually is a school in Portage. This is Portage Lake Center Elementary. Slinkies are tough because it requires a lot of pipe. There's only over 50 miles of pipe in the ground here. But you'd never know it was there, which is also my favorite part of Geo is, well, favorite, and it's kind of a little bit of a hurdle for me as a Geo contractor, because once it's in the ground, no one has any idea we're there. So this is another view of that. You can kind of see us just backfilling the dirt. How deep was that? That was about 8 to 10 feet deep. So when we do a slinky system, it tends to be a bigger cut. Yeah, at least. We need to really get below that huge temperature swing. So not just below the frost line, but really to the point where we're not going to... You give me a call. That's all. Yeah, the deeper the better. So in your house, this is a more traditional home style system. This is a horizontal open trench. And all of these systems are closed loop. I'm not a huge proponent of open loop. They're a great way to get into a Geo market, but do you know how much water a traditional open loop system will use? In a home, 1 million to 1.5 million gallons of water a year. So if you're pumping that much water, how long, one, is your well pump gonna last? But two, that's a lot of energy. So if the point is to get net zero, we're kind of defeating the point by going to an open loop system. So this is just another cool picture. I had an excavator who was very nimble, got up on the roof and took a really cool picture, kind of showing that it doesn't have to be linear, that we can kind of zigzag this into a backyard, but this is the most cost-effective way to go with a closed-loop geothermal system. So this is kind of a cool illustration showing a vertical loop. When we talk about vertical loops, it's the most popular in like a downtown setting like this. Does anybody know of a project here downtown that has a vertical geo system? You do where? Catalyst? Yep, we did Catalyst when you guys, or we drilled your holes. Actually, the downtown market also has a geo system. 63rd District Court, the Kroc Center, they all have vertical geo systems. But if you visit the buildings, you don't know because you can't see it. But how cool is that? We are doing the Michigan State Capitol, 224 holes, 500 feet deep on the west side of the Capitol, which is a very cool project. So this is just kind of illustrating what those vertical bores look like, kind of a cross section if you were to cut it open. So this is what they look like. This is actually the Kroc Center. So the Kroc Center's loop field is actually located behind the building under the soccer fields. So this is a cool one. And this is, I just like pictures of drill rigs because they're cool and big and really expensive, so I like to show them off. But this is a project just south of Indianapolis. The nice part about this project is it's more of a district-style geothermal system. We actually served 3 triple barracks, 2 single barracks, and a dining hall with 1 loop field. So this is kind of, it's a mess. When we install it, I will never say that it's not because it's very messy, but once we get to the point, this is what it looks like when it's done. This is a recent Google Earth image. But with technology today, I can actually GPS all the data. So you see, you can't see anything that goes on with the geo system. This is where all the bores are. So you can see the parking lot is just full of bores. We have a distribution system. The other X's as you go around are points for vaults, so places that we can get in and modulate flow or isolate systems if maintenance needs to happen, but in all fairness, the maintenance that happens isn't on the outside, it's on the inside. The pipe that we put in this ground has a manufacturer's warranty for 50 years. So if the manufacturer is going to stand behind it for 50 years, the chances of it lasting 100, probably pretty good. So outlasting quite a lot of the buildings that we install today. So this is kind of showing the drawing. I didn't know what our audience quite was, so I thought I'd show the illustration of what it was before we installed it. So this is a house. Just kind of showing the bores and the fact that this is a beautiful landscaped lawn right out in Traverse City, right out on a point into Lake Michigan, and how easy it is to hide your heating and cooling system. Their actual biggest push was they did not want to hear air-sourced equipment run. They didn't want to hear an air conditioner outside. They didn't want to hear any outdoor equipment. So it's silent. They don't see it, they don't touch it, they don't hear it. This is one in Alpena. So as you can see, we kind of travel all over, but another vertical system, and this actually ends up being their driveway. So it's nice, a vertical system can go virtually anywhere. We drill through anything. Everybody likes the big picture of the rock. That this was actually at Kalamazoo College. And we had no idea we drilled through it until we went to dig it out of the ground. So it was pretty cool. And this rock actually now sits at the Blandford School here in town. So this is showing kind of the bigger scale of geothermal. This is at the University of Notre Dame. We did a very crazy project a couple summers ago. They had to rip up their parking lot anyway, so they decided, you know what, we've got to do all this construction, let's just put geo in right now. They actually won't touch this for a few years, but it was the investment in later. So they're already doing construction. So when we talk about retrofitting this into a commercial building, or frankly a home, if you're already digging something up, put this underneath it. Even if you don't use it today, let's size it for later. So this is another cool project that we're doing out on the West Coast. West Coast being California, not just here in West Michigan. But this is a cool project because we are actually installing this under the parking garage. So during construction, we are actually drilling down almost 400 feet, 700 holes, and they will build a parking garage on top of us. So we've got we're drilling right between the pylons. So we talk about geo and its environmental impact. As much as I love geo and I love what I do, and it does save money, but it is also incredibly environmentally friendly. So this is just a cool slide that talks about that a little bit. Sorry, I'm trying to breeze through so that we're staying on time and anybody can ask questions. So quick highlights. So these are the parts, this and then the next slides that talk about some misconceptions as to what geo can do for a building's design. So we talk about geothermal. You saw the cool pictures of dirt, which is what my geo pictures look like because we play in a lot of dirt. But it's talking about what does it do for a building. So the best part is, now I don't need rooftop equipment. I don't. If it's a straight geo system, now you can change the structure of your roof. So any architects in here that like the big, cool, beautiful pitched roofs, now you don't have to worry about putting a flat spot in to put an air handler up there. All of that can go in the building. So reducing the load bearing requirements as well. Distribution ducts can be reduced because now, just like the air source system, water source systems also have small cartridge style heat pumps. In addition, now boiler rooms. Spaces can be shrinked. If it's a 100% geo system, I just need a couple pumps that distribute just like a traditional boiler system would be, but now I don't need a boiler. I don't need a boiler technician. I don't need someone to go out and service a chiller because it could just be 100% geo. The last one, which is my favorite one, especially to talk here in Grand Rapids with some big, beautiful historic buildings. Geo's great for being able to space condition a historic building, because what can't we do to a historic building is change the outside envelope. So instead, if you want air conditioning in your historic church or your historic building, put it under your parking lot, put it under your green space. And now I haven't changed anything on the outside, but I now can use that space all year round and be as comfortable as I want to be. Ease of maintenance. So I kind of touched on this briefly. So with a 100% geo system, it's a fairly simple system. I have pipes in the ground that don't need any help. And then I have pumps in the building, heat pumps in the building, that I don't have any water treatment necessarily. It can be 100% water. I don't have a boiler technician that I have to find, and let's say something goes down on a weekend, how difficult it is to find that guy. Or a chiller that is large and not always the most beautiful thing when we're talking about some cooling towers too. So that's very nice. And then extended efficiency. So when we talk about conventional equipment, they have a life expectancy. Even if we say we've all seen old buildings with boilers that are 30, 40 years old. How efficient is that boiler, one? But two, I don't ever have to do that. I don't have to replace anything. This loop field will be there forever. So let's talk about some misconceptions. So Scott touched on it a little bit, but the ground's only 50 degrees. How can that possibly heat my house? So Geo works, in all fairness, any of these heat pumps work with refrigerant. It's the magic of refrigeration. Works just like your refrigerator at home. You put something warm in the refrigerator, that refrigerant coil in the back is very reactive and will absorb that heat, and then it rejects it at the bottom of your refrigerator. There's cool YouTube videos you can watch. There's a lot more detail to it, but in general, it's rejecting the heat as air at the bottom of your refrigerator. This works in the exact same way. But instead of us rejecting that heat out into space like the refrigerator does, we're going to reject it into the ground to store it for later. And then there's a little valve that reverses and says, yeah, I'm not going to cool anymore, now I want to heat. So now it does the opposite, where now we're going to bring warmer temperatures into the building to then heat. It's completely run by electric. There's nothing renewable about it. Hopefully I don't have to super explain this in this room, but as Scott mentioned, for every unit of electricity that I bring in, a Geo system will put out 4 or 5 units of heating and cooling. So this is my favorite one, because I hear it a lot. Geothermal is so expensive, I'll never see the payback on that. Well, that's not true. When we talk about payback, traditionally, most of the time when people talk about payback, they're only talking about the operational expense. We're only talking about how much is my utility bill affected. The thing we're not talking about is how much maintenance is affected, how much downtime is affected, how much replacement cost I have. So for that boiler that's 30 years old that I have to replace, now I don't need to. So it's dramatically, it's huge. The cost savings, when we look at more than just the utility savings, is massive. So a few more, what can Geo do for you? So unmatched comfort and reliability. When talking about residential, this is a call we get way more often than not, that the geothermal system won't keep up. So my first question I ask them is, are you programming your thermostat? Well, yes, it saves me money if I turn it down when I'm not home. Yeah, not at all. A Geo system actually is a tremendous amount more efficient if we just set it and forget it. Because when you set your thermostat and you set it down, and then you immediately say, nope, I want it to be 5 or 7 degrees warmer, the heat pump's gonna go, holy cow, I'm not happy, because the thermostat's not happy. Now I'm gonna have to go into second stage. Now I'm gonna have to run even harder. Maybe I have to kick on that electric resistance backup that some of these heat pumps have. It's incredibly expensive to run. So geothermal, much more efficient if you just leave it alone. No combustion. So as Brett was talking earlier, our goal is to get rid of combustion. Geo doesn't have any. There are some units out there, as Brett had mentioned earlier, that will be a combined unit. So it's not just Geo, but the backup, instead of being electric, can be gas. Natural gas is ridiculously cheap. So to use that as a backup is a great idea for right now. Simple controls. If it's a straight Geo system, I don't have to do a whole lot. There are pumps to control, and that's about it. When we talk about big commercial systems, though, we do talk about hybrid systems. Geo is the most happy when it has a balanced load. I have equal heating to equal cooling. So sometimes we can use conventional equipment, especially if budget is a concern, it's gonna get a little more complicated, but in general, we can then kind of balance those loads out. A multitude of delivery options. I don't care if you want forced air or if you want radiant in the floor, Geo can do both. No outdoor equipment required, so as I mentioned with that home, now you don't have to have equipment outside. I don't have to worry about, especially in the city, how many times have we heard that condensers have been stolen or that they've been robbed of their copper. Now I don't have anything outside. We've actually done habitat homes this way in Lansing, and those homes only require a bore, maybe 2, and we can do it right in the driveway, in the front yard, in the backyard. It's very, very compact, very, very simple. Lower utility operating cost. That's a given. As I mentioned, lower maintenance cost, reduced footprint requirement. So unlike a solar panel, I don't need anything above the ground, so I can be very easily under a driveway. So how much easier is that now I don't have to have a structure outside? And longer equipment life, a heat pump, even an air source heat pump, has a traditional, much longer lifespan than a gas-fired furnace, especially because now we're not losing efficiency like we do in something that's combustion. Oh, I turned it off. Okay, so I kind of went through it quick. Sorry, I was trying to hurry for speed time. But any questions?
You didn't mention you had ponds listed, but you didn't cover ponds. What are the concerns with pond use? I've done a couple of ponds.
Size. So we get phone calls quite often that they say, oh, I have a pond, I'd like to put a geosystem in. But even an average home at least needs an acre of pond, and I need it to be some fed of some kind. And it needs to be 10, 12 feet deep because I can't let it freeze. So there are wonderful pond systems. The Boatworks out in over towards the lakeshore has a great pond loop system right under their docks. It's a great way to put it in. Very cost effective, but most people don't have that quantity of water in a pond they own. And we can do it in public waterways too. But the permitting process is so extensive, a lot of people just don't have the time to wait for that. I mean, it's up to 6 months.
What is the payback period for a geothermal system,
Propane, 5 years-ish. I mean, especially with some of the craziness that we've had lately with the cost of propane. I mean, a few years ago when we had that ridiculous winter and propane went up to $3, $4 a gallon.
That year.
I mean, that's insane. So it is fairly quick. And right now, I mean, propane's not terrible. So that's what we say about 5 years, but traditionally we say 3 to 5.
The payback cost on that can be slightly lower depending on where the customers you're looking at working with are located, if they're a member of like a rural cooperative utility.
So that's huge.
Significant rate credits available for their members that heat with geothermal. They also get significant rebates back on those.
So that is a huge point. And my biggest complaint, sorry consumers, that you don't have a prescriptive benefit for residential geo in order to get a rebate back. Sorry, but DTE totally does. Not to give you a hard time at all. But yes, co-ops and whoever your electric supplier is, huge reduced rates. Sometimes it's even a separate meter for the heat pump, and it's a dramatic difference from your traditional operating rate. Any other questions?
We live comfortably here in Michigan with geothermal only without any supplemental system.
Yes. I had a 2,600 square foot ranch, and I was down by Gun Lake, so in that crazy snow belt. I never changed it from 70.
What was your tonnage on a house like this?
3. Yep, because I was a walkout ranch in the basement. So not a ton of load in the basement, but it was a 3-ton, don't listen to Scott, Bosch unit, but it worked phenomenally. I didn't have issue 1. And to be completely fair, I saw there were a couple of realtors in the room, but the people that ended up buying my home bought it because it was geo. I didn't have a garage, and they chose the geo system over a house with natural gas with a garage.